In this video, I'm going to explain amplitude modulation in that it's a bandwidth spectrum and it's sidebands. Sidebands and frequency domain, coming to that, AM generates new frequencies. When modulation takes place, it generates new frequencies, which are called side frequencies or sidebands. When only a single frequency sine wave message signal or modulating signal is used, the modulation process generates two sidebands. If the modulating signal is complex wave, such as voice is of 300 Hz to 3 kilohertz, or video, a range of frequencies, then modulate the carrier and a whole range of sidebands are generated. In this case, only one single frequency, but when coming to the group of frequencies are modulated, then it will generate a whole range of sidebands. Then coming to the AM expression, VAM is equal to, this is the VZ sine 2 phi FCT plus VM sine 2 phi FMT sine 2 phi FCT, where this FC is the carrier frequency and VC is the amplitude of the carrier and VM is the amplitude of the message signal, sine 2 phi FM, and again this is the message signal frequency and carrier. So this is about the VAM, and when we here it is a sine A sine B. When we expand this, this is the VC sine 2 phi FCT plus, when we expand trigonometric functions, this is the VM by 2 cos of 2 phi FC minus FMT minus VM by 2 cos of FC plus FMT, cos 2 pi of FC plus FMT. Here, coming to the frequency component, there is a one frequency. This is called as a carrier frequency, and this is a FC minus FM and FC plus FM. These are the two side bands, and this one is the carrier. That is the first term is the carrier, and this is called as a lower side band, and this is called as a upper side band. This is the lower side band, and this will be the upper side band. And upper side band is this FC plus FM, and lower side band is FC minus FM. And this is the spectra. When we drawn this, this is the carrier. FC is the carrier, and from this, and again FM is the message signal. Upper spectra for single frequency is FC plus FM, and similarly FC minus FM. So this will be the total bandwidth occupied by the message signal EM. We will take one example. 400 Hertz, this is actually a message signal. Tone modulates a 300 kilohertz carrier. 300 kilohertz is a carrier and it is a message signal 400. The upper and lower side bands are FC plus FM, that is a 3 kilohertz, plus 400 hertz, that is a 300.4 kilohertz. FC minus FM 299.6 kilohertz. Next, coming to the voice frequencies, that is a 300 to 3 kilohertz. If the carrier frequency is 2.8 megahertz, that is a 2800 kilohertz, then the maximum and minimum sideband frequencies, that is the highest frequency component in this is a 3000. This is the highest frequency, 3 kilohertz. Voice, okay, the bandwidth is from 300 hertz to 3 kilohertz. In this highest frequency is 3 kilohertz. Then we will find out the upper side band is FC plus FM, that is a 2800 plus 3 kilohertz. Lower side band is minus. What this 3? It is the highest frequency of the message signal. That is a 2803 kilohertz and 2797 kilohertz. The total bandwidth is upper sideband minus lower sideband, that is 6 kilohertz. The difference between these two. And also, when coming to the AM, bandwidth is simply twice the message signal frequency. What is the highest frequency? 3 kilohertz. So 2 into 3, 6 kilohertz. In this way also we can calculate. And this can be graphically we have shown like this. This we can show here. 2800 is the carrier, and from this to this it is a 300 hertz because message starts from this FC, and this is the means 2800 kilohertz plus 300. This starting, and coming to this it is a 2803 kilohertz means 2800 plus 3 kilohertz. 2800 minus 3 kilohertz. So that will be the frequency 2797. 2797. Here 2797 kilohertz. 2797. A standard AM broadcast station is allowed to transmit modulating frequency up to 5 kilohertz. If the AM station is transmitting on a frequency of 980 kilohertz, compute the maximum and minimum upper and lower side bands and the total bandwidth of the AM station. Upper side band FC plus FM, 980 kilohertz is the carrier, 5 kilohertz is the message 985, and FC minus FM 980 minus 5 975. Bandwidth is upper sideband minus lower sideband 10 kilohertz or twice of that, that is a 10 kilohertz. And coming to the summary of the AM and how the broadcasting station transmit. The standard broadcast station usually is of 10 kilohertz, and stations means each station is separated by a 10 kilohertz with a spectrum of 540 to 1600 kilohertz. Means this is the bandwidth allocated, means this is the spectrum allocated for the AM. Starts from 540 and 1600. So usually each channel bandwidth is 10 kilohertz allocated. And the first AM broadcast frequency 535, because 540 minus 5, 535 to 545, one channel, like 10 kilohertz. And highest 1600 coming to that, 1595 to 1605. Then there are 107. How this 107? 1600 minus 540, that is a 1070, and divided by 10. So like this is the channels, okay, number of channels. And similarly we will take one more example. 3.9 is a carrier and 4 kilohertz is a message signal. Then what is the bandwidth here? FC upper side band 3.904, lower side band, this is the lower side band 3.896, and upper side band minus is equal to, then this will be of 8 kilohertz. Also twice of that means it is a 8 kilohertz. This is the bandwidth here. And 2.3 megahertz SSP transmitter, a signal 150 hertz to 4.2 kilohertz. Calculate the range of frequencies. And so now FC is 2.3 and frequency is 150 to 4.2 kilohertz. It produces upper and lower side bands. When FM is 150 hertz to 4 point, right side spectra, means with respect to the carrier right side spectra, that is FC plus FM, that is a 2.3 plus 150, 2.300150 megahertz, and 4.2 kilohertz, that is a 2.304200 megahertz. That is this is the right side. Similarly, coming to the left side, FC minus FM minus 150, 2.299850, and 2.3 megahertz, and 4.2, that is a 2.295800 megahertz. How it looks means like this. Okay, this is the carrier frequency. From this place to this place, it is a 150 hertz, and from this to this, it is a 4.2 kilohertz. Similarly, this is actually spectra. This blue color and red color. Left side spectra, right side spectrum.